This is lesson 3.2a. It'll be the first of several videos in elementary algebra called graphing linear equations in two variables. So when I say in two variables, that means if I have something like this, we have two variables. We have an x and a y. There are a whole bunch of numbers that will work to make this a true statement. I mean, I could use x equals 2 and y equals -1, because 2 times 2 minus 1 equals 3. I could use several other numbers to make this a true statement. Let's see. What I can do is, you're used to drawing this little table. I could put in 0 for x, and this becomes 0 plus what is 3? Well, plus 3. I can put a 1 in here for x. 2 times 1 is 2, plus 1 is 3. I could put in a 2 for x like I did earlier and get a -1. I could put a 3 in here for x and get 6 plus -3 equals 3. So the list goes on and on and on. And the reason I do this is if I want to draw a picture of this equation, I need to know where the line of that equation is. So then it's real easy then, making a really spiffy graph, to graph 0, 3, 1, 1. I'm not going into how to graph these because I'm assuming that you did this lots of times over the past couple years. I got 4 points and I get a straight line here. And you will always get a straight line when you have exponents on x and y that are 1s. And the answers that you get here are called ordered pairs. 0, 3, 1, 1, where the first number is always the x value, the second number is always the y value. And so that brings us to some examples here. So let's go ahead and look at example 1. And it says, alright, so we're going to give you some ordered pairs. We'll give you 2, 3, 1, 5, and -2, -4. So we're going to give those. And we're also going to give you an equation. Which ones of these make that a true statement? Well, let's do the first one. Y would be 3, and x is 2. Is that a true statement? Is 6 plus 2 3? No. So we throw that one out. Let's do the next one. 5. We'll plug that in for y. 3. X is 1. Is that a true statement? Yes, it is. So that works. Let's try the next one. Y, -4 equals 3 times -2 plus 2. So I have -4 equals -6 plus 2, -4 equals -4. True statement, so both of those work. So example 2 is giving you an equation, 2x plus 3y equals 6. And they're giving you some ordered pairs with one of the values in it. So I've got 3 of them. So they're asking you to find out what the y value is if x is 0. So we put 2 times 0, 0 in for x, plus 3y equals 6, and we're just solving for y. So divide by 3, divide by 3, y equals 2. So when x is 0, y is 2. Alright, and then it asks us to put 1 in for y. So we get 2x plus 3 times 1 equals 6. And this time we're looking for the x. So now my x value is 3 halves. Okay, so let's look at the next one. We have 3, and we're going to put that in for x. Subtract 6, so we have 3y equals 0, divide by 3, divide by 3, y equals 0 over 3. Anything over, or anytime you have 0 in the numerator, it's 0, so that goes there. So I just found out the 3 ordered pairs that make that a true statement. There's an infinite number, but we just looked for those 3 there. Alright, let's jump to example number 3. Complete the table for the equation y equals 2x minus 1. So we've got the table. You're all used to doing that, and they gave us 0, 5, so we're going to look for 4 of them. 7 and 3. So we're going to put 0 in for x there, and 2 times 0 is 0, minus 1 is negative 1. Let's see if we can do these in our head. Put 5 in for x. 5 times 2 is 10, minus 1 is 9. Now we're going to put 7 in for y. Can't really do that in my head as easy, so I'm going to go 7 equals 2x minus 1. Add 1, 2x equals 8. X is going to equal 4. And for the next one, I'm going to put 3 in for y. So 3 equals 2x minus 1. Add 1, I have not 2. I have 4 equals 2x, divide by 2, so x equals 2. So I just completed that table. So that's example number 3. Alright, so the next section we're going to look at is called graphing linear equations into variables. And that'll be the next lecture, 3.2b.